Love. All our material is open source. We also only use open source tools. So all the tools are free. You don't have to pay $1,000 a year for STATA memberships, SPSS memberships. We're by using free software. Additionally, beyond the 2-day workshops, all our material is live on our website. So we're going to provide you those links. So if there's something that you struggled with that we couldn't answer in class today or tomorrow, you'll have all of it available to review at your leisure.
Yeah. All right. So, so let's get rolling. The important things to get started are, I think, first that you've downloaded and installed the appropriate software. So this morning what we'll be using is some kind of a spreadsheet tool. I'll be using Excel on my computer, but something similar. If you don't have Excel, Google Sheets is fairly similar, something like that. Also that you've downloaded and can open Refine. And last is that you have access to, this is the Etherpad, and there's a link to this from the workshop website. So if you click on this, this is where we can kind of talk and write notes, and we have some links in here already. We'll probably be popping some other links to data files and things in the Etherpad, but just go ahead and make sure that you can access the Etherpad, and we'll be able to tell that everybody's in there when we have your different names here. So maybe the first thing to do is to go ahead and open up the Etherpad, put your name in there, make sure that you can open both a spreadsheet program and open Refine, and once you do that, I'm going to actually, while we do that, I'm going to come around and pass out some stickies, and we can use these.
And while Jacob passes out the stickies, for your reference, Etherpad, this is another open source software run by Firefox. So we're using this as note-taking and collaboration today and tomorrow. So for all of you here, you can take notes on Excel and share it. It's a living document. It never goes away. So after the 2 days, you can reference it for material, links, and resources. Once you have it open, as Jacob said, pick a color, put your name. It also works on mobile. So during the course of the workshop, myself, when I'm not teaching, Esther, our helper in the back of the room, and our other helpers will be on Etherpad. So if you don't get a chance to ask a question out loud, feel free to ask questions in the chat, and we'll answer to you directly. Also, Jacob's passing around green and red stickies. So for software carpentry, we're all about empowering you to have questions answered. So if you ever are getting stuck with technology or so forth, put a red sticky up on your computer. One of the helpers will go around to you and will help you out. So if you don't get a chance to verbalize your question, you can put the red sticky, will go around. We'll have formative assessments over the 2 days. So we might have a challenge, like a code challenge for you to do. And we'll say, when you complete it, put a green sticky on your computer. Or if you're struggling, put a red sticky. What else? Additionally, on the Etherpad, we have up here our names, so the instructors, the helpers. We actually have quite a few helpers, so I'd love to have them all say a little bit about themselves, and so you can know who they are. So Minglu Wang, so she's our coordinator. Yep, so she's our coordinator and here at the Dana Library. Do we have Bonnie Fong here?
Hey everybody, I'm Bonnie Fong. I'm the one who's been sending you all those emails. I'm the Physical Sciences Librarian and Head of Emerging Technologies at Dana Library.
Awesome, so she'll be helping us out with tech as well. Ann Watkins? Not yet, okay, no worries. Stephanie Mikitish.
Hi, that's me.
Awesome, so she'll be helping us out also. And then Esther Jackson.
I am a librarian at the New York Mechanical Garden in the Bronx.
Yeah. And what's so cool about Esther, so not only is she like my mentee, so I have great passion, and it's great to see Esther. She's gone through the data carpentry program, so she's actually taken most of this material, so she's familiar with a lot of it. So she'll be a great resource for you. She's only here the first half of today, but you're here all of tomorrow. Yep, so she'll be here today for Excel and Open Refine, and for more advanced Python and SQL tomorrow. Additionally, we have a section on here called Learners. So I'd like everyone to put your name, the department that you're studying under or working under here at Rutgers. So if that's like MBA, PhD, part-time student, you know what that looks like for you. Your email address for other students to reach out to you. So beyond the workshop, if you guys want to connect, create study groups, work on projects together, great way to pair and connect. And then your Twitter handle as well if you want to tweet about the workshop.
What our steps and the work that we've done has been. So that's my first kind of recommendation, is that when we're working with Excel and we're working with or some other spreadsheet program like Excel that's primarily a point and click program, okay, we're going to be interacting graphically with it as opposed to writing some sort of a script to it. We want to keep track of what we've been doing. So for example, this is just some potential tab of notes where I'm keeping track of each step that I'm going through and acting on some raw set of data. Now the other thing that's very important then is to keep my initial set of data, my raw data set, raw in some version. Okay, so I'll be transforming it and doing some operations to it to clean it and manipulate it, but it's also important that I always have that initial copy of it somewhere. So the two big kind of principles that we're going to begin with are keeping track of our steps for manipulation and keep making sure that we keep the raw data raw. All right? The next thing that we want to kind of consider is about the structure of data. So the data set that we're going to be looking at is an ecological data set. And here's a potential kind of slice of that data set. If you look at this data, we have columns for the date collected. There's a number of different plots. These contains the plot numbers, the species and sex column, and a weight column. If you look at this data, can you think of anything that might be done to improve it organizationally? Mallory, is that?
Yep, if you split it up, the species and sex columns,
How come?
because then you can sort by that info in two different ways.
Yeah, there's like right now there's two pieces of different information in that column, right? So it could be improved if instead we had each of those in their own column, like a species column and a sex column. Absolutely. And that's one of the kind of principles that we're going to start with, is that each column should contain just a single piece of information, okay? A variable, right? One variable per column. And each row will be one observation of that, all right? So if you take a look at the Etherpad, we have there's a link to the first Excel data file. What I would like you to do is go ahead and download that file to your computer. If you click that link, it'll download the file to your computer. And if you open it up, you should have a spreadsheet that has a few different tabs. If you notice, there's a 2013 tab, 2014 tab, and a third tab for dates. So our task to begin is going to be to take these 2013 and 2014 tabs and combine them and clean them up, cognizant of those kind of ideas about data organization and keeping track that we were just discussing. So for the next about 15 or 20 minutes, you and the person next to you, what I would like you to do is to take the 2013 and 2014 columns and attempt to clean them up so that somebody could then begin to perform some sort of analysis with them, okay? Again, keep in mind those different principles that we talked about. Each column should have a single observation, or one variable, each row, one observation, okay? Keep track of the steps that we do to manipulate the data and keep a copy of the raw data. And again, if you run into problems, go ahead and put that sticky up. first, if we look at this 2013 table, somebody tell me one thing that should change about it. Yeah. Oh, okay. That we have a column of weights with grams in here, and then we have other weights that don't have the unit, right? So to make those all the same. What else? Yeah.
Creating a column for species.
Oh, okay. So right now we have 3 tables, each of them for a particular species, right? That instead, like we talked about, each of those should be its own column or an entry in a column called species, right? There's a variable called species. Yeah. Great. What else?
Year also.
The year. What about the year?
2013 for this, and the other one is 2014.
Oh, okay, yeah. So if we look at the other tab for 2014, right? We see some differences in the way that the dates, like this column here, in particular, right? A little bit of a different date format. What else did you notice about this? Yeah.
Missing data that's not flowing.
Yeah. Okay. So. Like this blank here, and this blank, maybe we should do something different. Yeah. Okay. Yeah.
Create a new column to indicate if the value has been calibrated.
Oh, okay. So like there's in these 2 entries, it says that the scale is not calibrated, and then in this one, we have some conditional formatting where there are 2 entries that are gray because the scale's not calibrated. And rather than having either the conditional formatting or the different format of the cell itself, we could have a column that says whether or not it was calibrated. What would that column look like for you?
For me, it just says calibrated and S of per unit.
Yeah, Y or an N? Yeah, that's great. Great. Who has other things that they noticed about the data that needs to be changed? Yeah.
In 2014, it's listed as plots, and in 2013, it's listed as species. So we would need to create either a plot or species column.
So that there are some variable names that are a little bit different across each. Yeah. Anybody notice anything else?
In plot 3 of 2014, year is not given.
Yeah, there's no year given in this plot, right? Plot 3. And again, as you just mentioned, this is just like the earlier one, that each of these tables goes with a species, right? Each of these goes with a plot. So we have to create that column for species in the 2013 data. In the 2014, we've got to create it for the plot. Yeah. What else?
Someone already mentioned that
There's
there's 1978.
a 1978 plot here. Yeah. And that's supposed to be 2014, I thought, right? Yeah. Yeah. Great. Anybody have any other alterations that they made to the data? Changes that they made? Yeah.
You can, 2014 in plot 3, if you click the date column, you can see a year as well.
Oh, if I click on this, it tells me that it's 2015.
Yes.
Yeah. Yeah, okay, so we've got some work to do with the dates.
Oh,
Yeah.
also you can
No, that's what is 2000.
Yeah,
narrow
Grace?
down the male and female species on the bottom one, plot 4.
In here, we have this species that is both species and sex.
Yes.
Yeah.
So you separate that.
So we've got to break that apart. Okay. Great. Yeah, excellent. So again, what we're doing here is we're just kind of coming to terms with these conventions about how data should be organized, right? Like when we get into Python, or if you deal with R, there's going to be certain expectations around the way that your data is formatted before we can use a lot of the libraries within. So we're just trying to get you to adhere to these standards. There's a link on the Etherpad to a nice article by a guy, Hadley Wickham, about tidy data. Okay, you'll see that word kind of come up a lot in the data science community around tidying your data. It's just a kind of conventions about rows and columns, columns having a single kind of variable or feature, and each row being a single observation. Yeah, the other things that we ran into here, conditional formatting. We'll talk a little bit more about conditional formatting in a second, but it's something that we want to avoid. All right, coloring cells to highlight something, because when we move this into a different program, it's not necessarily the case that that formatting will come through. All right, and that's a very important idea, is that we're able to kind of move from program to program with our data set. Okay, so so let's look at the time a little bit more, and there are some things that we can do. Oh, I should talk about the null values. You did mention the blanks. So we have some options for dealing with values that we don't have, right? And there's some different ways that you might see these occur. But some things that we want to avoid are zeros, right? If we have a 0 in where we don't have a measurement, that's different than actually measuring nothing. Right? So we don't want to include zeros as ways to indicate like a missing value. If it's blank, well, then we don't know what that means. Does that mean that it wasn't measured, or does it mean that there was nothing there? It's hard to distinguish sometimes, all right? And the preference is going to be to use NA. In particular with R, NAs are easy to distinguish, okay? We'll see a lot of you'll run into a lot of functions in both pandas and in R that involve NAs, drop NAs, and so on, okay? So NA is a kind of a canonical form for dealing with missing data that you should use rather than zeros and blanks, okay? Although blanks will still be okay in Python and R. We talked about the formatting to instead use a new column. And last is the column names, okay, field names. Something else that we want to be careful of is using funny characters and spaces in particular, in things like column titles, but also file names. I mean, it just should be kind of good practice, like to not use spaces in for important names in your data, okay? So for example, if we have something like a maximum temp, what we don't want to do is we don't want to name that column maximum space temp, all right? Instead, we could either combine it as one word, max temp, or we can use underscores to separate the values, okay? Same thing with precipitation in millimeters, like this press millimeter. What might be problematic about this as a column name?
The units.
The units?
It's vague.
It's vague, right? Like if I give this to you, right, and you see this column press mm, do you immediately know what it is? Like it's not that clear as to what that's describing, right? It would be better if we had precipitation, or if we had precipitation underscore mm, then we would. I like this one even better, right? Mean growth per year, right? A space and a slash character, right? Better as a single word, mean year growth, or separated with underscores, right? Male, female as sex, again, the character there. W for weight, we've got a period. Cell type is a space. First observation, this is another problematic column name. What do you think is the problem with first obs? Maybe there's two problems there.
Space.
Yeah, it begins with a number, right? We don't want to start with numeric values, and also that it has the space. So a better choice would be to actually spell first. underscore observation, or to write out observation and then followed by a number. It's okay to have something like observation underscore 01, but we don't want to start the name with a numeric value. Okay? Yeah, okay, so dates. You know, we need to talk a little bit about how we should format dates. There are functions in Excel that help us to extract some of this information. Let's try using this. We have a little tab that's a dates tab in our data as well. And if we take a look at that, if we click on this dates tab, we just have a couple of entries here. And let's look at I'm going to create a new column called year, a new column called month, and a new column called day. And the function that I can use to pull that information from the existing dates are, I mean, they're kind of obvious. It's year, month, and day. So if you haven't used a formula in Excel before, while you're in the cell that you're going to use the formula in, you type equals, and then you begin typing the actual function. So here I'm using year, so we're going to type year. You see that the year function comes up, right? So I can select that, and then it gives me the instructions about what to do with this. Okay, now I just need to go and find what I want to find the year of. So I can click on this cell, for example, and hit enter. You see it gave me that the year was 2015. So to extract a year, there's a year function. To extract a day, there's a day function. To extract the month, there's a month function. Okay? Go ahead and try and use the month function and the day function to extract the month and day of this first entry here. How do I get the month here? What do I need to type? Equals month, and I can just point and click and enter. Yeah, okay. And day equals day, parentheses, A3, close parentheses, enter. If I want to apply this formula, does anybody know how I can have this applied to all of these rows?
You click the bottom, well, on the bottom corner where it comes up with a little X, and then drag it down.
Yeah, I can just drag these and apply, and it looks like everything is in 2015. There's my different months, and here are my different days. Okay? So just pointing and clicking can apply that same formula.
Jacob, do you want to show them that they can, if you undo, you can just click on the black cross. So if you do Apple Z, so just undo once.
Oh.
And then click, and then at 8, you can, on G3, where it says 8, if you click on the bottom right of that cell, when it's a black cross, you can just, yeah.
Yeah.
Just be like, you can click on the cell first, and then double click, just double click, and boom. So like, super cool. The reason I just added that in for you guys is it's way more efficient to double click, and Excel automatically goes to the end of your data. Dragging and dropping, if you have thousands of rows, isn't super efficient. So just more efficient.
Jacob, will you
Yeah.
just do it once more?
Yeah, so let's see. If you just, while you have that formula in this cell, if you double click this little corner, it fills the column.
Yeah.
So that's one set of the date functions. There are also some functions that give you kind of the current time of day. We can use those to figure out, like, to enter the current date of some sort of measurement that we're putting into our data and so on. But let's play around with these a little bit. I want you to try and use the now and today functions to calculate the current time, and then I want you to pull the hour, minute, and second out of that current time. Okay, so we can create a new column that is the current date with the now function. The current time can be found by subtracting now and today. And then from that, we can pull the hour, the minute, and the second of the present time, okay, using the hour, minute, and second functions, just like the month, day, and year functions, okay? So go ahead and try, generate that new column for now.
We need not select any particular date or something for now or today.
For now and today, what it's doing is it's giving you the present time, right? So we don't have to reference anything within that, right? And if I wanted to, I could ask, like, the first thing we did was we looked at the year, right?
Yeah.
I could look at what year it is now. Like, I could say equals year, and in parentheses say now, and it tells me it's 2018, right? So similar here, what we were asked to do was we were asked to create a now, right? Now gives me, and look at what now gives me. It gives me the date and the time, right? So it says 1/11/18 at 10:09 a.m. Okay? Now, if I subtract today from this, well, the part of it that's today is just this 1/11/18. So if I subtract the today from it, then all I'm left with is the time, right? And then from that, I can pull the hour, the minute, and the second. So if I have equals now minus today, okay.
You can format it to time and it'll.
Yeah.
Great.
So we notice a decimal number here. This is kind of Excel's default way of dealing with this object, and we'll talk more about that in a second. But yeah, that's
Hour, second?
It's the time in
Hours.
days.
this decimal. I don't know. Actually,
Yeah, like a percentage of the day.
Yeah,
You ever see that
4.42.
that
Ah,
graph
well,
that
that's-
says that everybody
it's a
thinks
difference,
is
but it's a fixed time.
everybody thinks it's like the debt rolling thing, but it's actually a clock.
When we get
That's
to
time. Yeah.
I could throw some insights, but are you just doing formative assessment, or do you have thoughts on it?
no, I was going to talk about the 1899 date in a second, but this
It's
is
just formatting, actually. So
Yeah.
Which is what you're kind of going into. So,
Yeah. yeah. So this is not, it's not formatted correctly. Yeah. So change the format, and if I change it to date, it's not quite what I wanted, right? What should I change it to format it?
Time. Yeah.
Oh, okay. And that looks right,
Yeah.
right? It is about 10:10. Okay. So what did we do? We got the present time by doing that subtraction, by doing the now minus today, and we have the hour, the minute, and the second. If we want to pull each of those for an individual observation, right? Like how do I pull the hour from this? Yeah, equals hour. So maybe I want hour, minute, and second. Right? Then this will equal hour, and of this guy, minute can equal minute of the same cell, and second equals second of the same cell. So the preference for dealing with dates and times is going to be the same as what we had discussed with other features. That we want month, date, years as it's their own columns is going to be best. Okay, things get problematic when they're mixed together. So it's not that that's going to always be the case that you see the same format in every with dates in every data set, but I believe it's better to have them separated into different chunks, and that's also what we kind of recommend here with data carpentry. Okay? All right. So that's handling dates, a little bit of the functionality with Excel and date formatting. If you save, if you were to save this file as a CSV file, so if we were to go ahead and file save as, and save it as a CSV UTF-8, and if we save that to our computer, it's going to ask you, it's going to say, oh, listen, there's more than one sheet there. Which one do you want us to save? If you click Save the Active Sheet, then you can go ahead, and one of the things that we asked you to install was a text editor. If you have something like Notepad or some other plain text editor on your computer, you can open that CSV file in that text editor. And so here I'm using a Sublime text editor. It's any kind of text editor. And if I open that data that I just saved, if I can remember where I saved it.
CSV UTF or CSV?
Yeah, CSV UTF-8, right? This is the kind of file that we'll save it as, comma, separated values. Save the active sheet. And then if you go to a text editor and open that guy up,
What's the name of the one you had us download?
this one is Survey Data Messy. Survey Data Spreadsheet Messy.
I mean, the text.
It depends on your operating system, which one you downloaded. If you, I think on Windows, what does Windows tell them to download?
The default text editor, or the file to download?
The text editor.
There's many ones. We have Notepad++ for
Is that-
software carpentry. We also recommend Sublime Text. I could also recommend for you guys Atom, which is really good. And Microsoft Visual Studio is actually really good as well. I'll write those up on the Etherpad for you.
So Sublime is a free text editor. There's a number of them. If you download Sublime, every once in a while it'll ask you to buy it, but you don't have to. You can just keep using it.
So the four that I just put in the Etherpad comment, Notepad++ is free, Atom is free, Microsoft Visual Studio is free, Sublime Text isn't free, but they all work really good. So you can play around with them and see what you like is your preference.
So you should be able to see something like this when you open it with your text editor. Is there anything funny that happened with the dates as a result of kind of changing where I was looking at this file? Like, did anything funny happen to the dates when you opened them with your with the text editor.
Okay, so open it with. Thank you.
Oh, they split.
What happened?
They split.
They split. Yeah, it,
First one.
like this one 1/8, right? If I look at it in my notebook, it's right. The entry in here is 1/8/2015, but I don't think that that's what it shows as the entry in my text editor. And now the other thing that we can do is we can go ahead and reopen this back in Excel. So if I find and open, I'm going to go ahead and open and need to find this file again. What's this one? So if we reopen that CSV file in Excel, you should notice that again the dates have changed. Right? So just by saving it as a CSV and then reopening it with Excel, we see that if we had left those dates as is, it would reread them differently. So that just means that if you were maybe collaborating with somebody and you saved your file and shared it with them and they opened it, you'd have two different columns for dates, depending. Okay, so that's one reason that we should be kind of careful about how we format dates, especially if we're using Excel to perform that formatting. Okay. So just make sure it's also good that you're able to kind of save things. You want to be able to save things as a CSV. You want to be able to find that CSV file on your computer, reopen it with Excel, okay, or a text editor. These are going to be kind of things that you'll do consistently.
And just one more comment to text editors I mentioned. Just in my preference, Atom and Microsoft Visual Studio, I think, are the two best free ones, and they work on Mac, PC, and Linux. Also, Notepad++ and Sublime Text do work on PC and Linux, and Sublime Text works on Mac. But Atom and Microsoft Visual Studio are generally better. Not just because it's Microsoft, but they actually make really good extensions.
Okay, everybody good with the time piece? All right, great. The next thing that we're going to talk about is a little bit of quality control, quality assurance, quality control. Yeah, so let's go ahead and open, make sure that we have that file open again in Excel. Let me open my file here. And let's go ahead and look at data validation. So the first thing that we're going to look at is what we'll call quality assurance. And quality assurance, we're going to be thinking about this as something that we would do before we enter our data, all right? And the reason that we're doing it is to limit ourselves to only being able to enter a certain kind of data. If we're entering some sort of quantitative information, then a slip of my hand and a couple of letters in there could really screw things up down the line, especially if I have a bunch of data, if I'm doing a ton of data entry. All right, so the first thing that we'll look at is how to assure that that won't happen. So if you click on the data tab for Excel and look at data validation, we click this data validation, then we see this box come up where it says validation criteria, any value. Now we can change this and we can the kind of values that we allow to appear in our data entry by selecting any one of these that we care about. So for example, if I select whole number, and then I have options for what I'm going to allow that whole number to be. Maybe it can be not between, equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to, okay? So I'll pick greater than. Actually, I should pick, let's see, between. I'm going to pick between. And I'll pick between 1 and 24. So now if I go into one of my cells, like this plot cell, and I try and enter 35, well, it let me, because I didn't select, I forgot to do one step. I forgot to select where I was validating my data. So if I go ahead and I select this plot column and go into data validation, do the same thing. I'm going to allow a whole number between 1 and 24. And now if I try and change something to like 84, yeah, I should get this error message. And it says that the user has restricted values that can be entered into this cell. So again, what we were doing was we were setting it up before we went about entering the data in order to give us a warning if we enter something bad. All right, so now what we've done is we've limited ourselves to only being able to enter whole numbers between 1 and 24. Okay? And we get this error. Well, we can actually customize that error message if we'd like. If we go back to the data validation choice, yeah, that's okay. You can see that we have, besides for our settings where we said I'm going to only limit this to whole numbers between 1 and 24, there's an input message bar where you can input a custom input message that will be returned upon changing values. Okay? So if you don't like that default message, you know, maybe I want this to be error, and input will be you can only choose from 1 to 24. And I enter that, and now you can see that error message come up when you choose or try to enter something inappropriate. All right? So that's quality assurance. Right? Before we entered data, we were setting up some kind of roadblocks to if we entered something incorrectly. We can also do the opposite, where if we have all of the data and we want to look for some problematic values. Now, this is one example of where we'll use conditional formatting. So, for example, maybe if I choose this weight column, and we can choose conditional formatting. And let's say that I'm going to make a new rule. So I choose new rule. And if I choose the 2 color scale between the lowest value and the highest value and click OK, well, nothing happened here. Why do you think nothing happened for me?
We didn't mention the lower and the highest values.
Say that again?
We didn't mention the lowest and the highest values.
Oh, okay, yeah. Well, what I meant it to do was to actually select like the lowest and the highest values from that column based on those colors. But
Is it not recognizing as values because of the G?
yeah, so look, let me go ahead and I'm just gonna copy and paste like these values that are weights right under this. Okay, so now I have some numbers that have grams or the letter G with them, and some just regular numbers, and I'll try to do the same thing. And now we note that it did apply the formatting. However, it only applied the formatting to things that were numeric, right? So this could be a way to kind of quickly hone in on some non-numeric values, some problematic things that aren't the kind that you want in there, right? Like, just like before I said I only wanted numbers between 1 and 24, maybe I instead, this is a different situation where maybe you've gotten data and you're trying to see are there non-numeric values in there or something like that, and you can use the conditional formatting to search those things out, okay? All right, but again, like we don't want to leave a spreadsheet like this with the color formatting as conveying some sort of information. We're just using it quickly as a tool to kind of highlight something, and then we can undo and right those wrongs and eliminate the coloring and stuff like that, okay? All right, the last thing that we want to do is, yeah, we just want to make sure that everybody is able to export the file as a CSV. After we've done some, we've talked about quality assurance, quality control. Next thing, after you have your data cleaned up, you just want to be able to export it as a CSV and keep it that way. The reason being is, again, you don't know that the proprietary software is going to be there some time from now, okay? If I save something as an Excel file, there's no guarantee that Excel will persevere forever, okay? Whereas you might want your data to persevere forever, all right? And so a comma-separated value file is a typical way to structure or to keep your data that will move from language to language, okay? You can upload CSVs in Python and R, but you can also open it with Excel, you can open it with Google Sheets, and so on. There's also tab-separated value files that you'll see from time to time. But CSVs are a fairly common way of keeping files on your machine. So just make sure that you're able to save as, and again, the CSV comma delimited file type here. You'll also see there's other options for CSV, the Windows comma separated and the MS-DOS comma separated. It won't make much of a difference which you choose to save it as, especially if you're talking about bringing it into a different program.
Yeah, generally use the UTF-8, which is the new one, because that's like universally compatible with Mac, Linux, PC. And CSV, just like Jacob said, is great. You can use it with SQL files also. You can use it with SPSS. I mean, almost any programming language, it's just this universal file.
Yeah. Okay, great. So that's our time in Excel. All right. The takeaways should be specifically like what it means to have tidy data. That again, each column is a single variable. Each row is a single observation. All right. With dates, how to break those apart, how we can use quality assurance and quality control to kind of highlight problematic values and clean things up quickly, saving things as CSV files. Yeah. We'll take about a 15-minute break, and then we'll get into the work with OpenRefine and see a little bit more advanced kind of data cleaning and munging activities.
Real quick before the break, some of you may be asking, wow, this is great on Excel, but I want to learn more. I'm so glad you asked that, because I'm putting 6 links in the Etherpad on what I think are my favorite Excel websites that teach you shortcuts, how to do more complex functions. Everything from Lynda, which is owned by LinkedIn, owned by Microsoft, Great Excel, Mr. Excel, Contextures, Excel Easy, Chandu, and ExcelJet. So lots of content if you're looking to learn more Excel. Great. See you guys in 15 minutes.
Yeah, we have coffee and some cookie.